Good morning, class. Welcome to another edition of Maths with Ablight.
The square of 5 is 25, so you put it in square root because the square root of this will give you exactly 5.
1 over x is equal to 27 raised to power x.
Express square root of 32 as square root of 16 multiplied by square root of 2.
X to power a plus b. Good morning, class, and welcome to another edition of Maths with Ablight. And today we're looking at the laws of indices. In this class, I just want to explain the laws. We're not really solving any serious questions today, but we're going to use them in another edition of this topic or another edition of the video to solve questions, but just to give you an overview of the 4 laws that guide indices or indicial equation. You've got x to power a multiplied by x to power b. This is simple. According to the law, it will just give you x to power a plus b. All you need to do when you have a multiplication, you change the powers to addition. Take one base and then add up the powers. In the same vein, or similarly, or conversely, if you want to put it that way, when you are dealing with division, what do? You subtract. Very simple. You say x to power a minus b. For one, it is plus. For the other one, it is minus. Remember, in mathematics class, speaking mathematics language, you say minus. Then x raised to power 0. This one is 1. By the laws of indices, anything raised to the power of 0 is 1. If today I am raised to the power of 0, I become 1. I don't become a human being. As you are watching me, if you are raised to the power of 0 immediately, you become 1. If there's anybody beside you watching this video and that person is raised to the power of 0, the person becomes 1. And that's why the only person in history that was ever raised to the power of 0 is... Can you remember the person? I'll write the person's name. Or if you like, what we have in that story is that this woman was asked not to look back, and then she felt she was too big, or felt, I don't know how to put it, somehow she found herself looking back. Immediately she looked back, she was raised to power 0. And do you remember what happened in that story? Those who have read the story, she turned to 1 immediately. And according to history or story or the story or legends, that 1 is still there till date. So it is from these laws of indices. To me, in my opinion, this particular law of indices took its root from that place. Anything they raise to power 0 becomes 1. If I raise this board to power 0, it becomes 1 immediately. You will just become 1. As you are sat there watching this clip, if you are raised to power 0, you become 1. Lot's wife was raised to power 0 immediately on the spot and she became 1. So if you remember this analysis, as we are solving questions and you see that anything is raised to power 0, you don't need me to remind you. I'm not going to see any student tomorrow writing 5 raised to power 0 is equal to 5. It means you did not attend my class. If you attended my class and you have listened to this illustration that if a human being is raised to the power of 0, the person becomes 1, then you will know that even 5 does not become 5 when raised to power 0. That is why I'm stressing it. Anything you have in that house as you are watching me now, even the phone you are using to watch me, your laptop, if you raise it to power 0 as we are talking, it becomes 1 immediately. And then finally, when x is raised to the power of negative a, it becomes 1 over x raised to power a. And these are the 4 laws of indices. Good morning, class. Welcome to another edition of Maths with Ablight. We're looking at indices. Indices is basically for people in SS1, SS2, SS3, thereabout. We're asked to simplify 10 to power 3 multiplied by 10 to power 2. This is no problem at all. All you need to do is to come here, write your solo here, shown. I'm sure you remember that in a mathematics language. Solo here, shown. Remember in the laws of indices, 10 to power 3 times 10 to power 2 takes you to the first law, which says x to power a multiplied by x to power b is equal to x to power a plus b. Just add up the powers, take one of the bases. So you have 3 plus 2, and that gives you 10 to power 5, which gives you 1 0 power 5. That will be 5 zeros, like 100,000. And that is your answer, even in Lagos. This is no problem. The next one is there, division sign, the second law of indices. Solo here shown. You've got 22 to be divided by 2, and then you have n to power 7 to be divided by n to power 3. It is simple. Slight cancellation here will give you 11. Slight cancellation here will give you 1. You cancel out the numbers. So you have 11 n raised to power 7 minus 3. And that is 11 n to power 4. And that is your answer, even in London. If you are going to simplify this, solo here shown, you've got 5 to power minus 2. If you remember in the laws of indices, x to power minus 1 is equal to 1 over x. Remember the minus 1 sign is changed to plus this time around. So this will give you 1 over 5 raised to power 2, which is 1 over 25. Simple enough. Then the next one says 24 divided by 8 with x to power 6 and x to power 4. You just simply cancel. Slight cancellation here jives. Slight cancellation jives. So when you write your solution, all you need to do is to say 24 to power x to power 6, 8x to power 4. When you slight cancel, you have 3. You are left with 3x to power 6 minus 4, and that is 3x to power 2. And that is your answer, even in Lagos. As simple as it is, these things can be very confusing. Always remember the laws of indices. This is on the first law, this is on the second law, this also is on the second law, this is on the fourth law. It did not touch the third law. The third law is simple. Here it says x to power 0 is equal to 1. I have already explained this in the previous video, where I told you that anything you raise to the power of 0 is equal to 1. If a human being is raised to the power of 0, that person becomes 1. Anything at all, even if this board you are saying you raise it to the power of 0, it is 1. In the next class, we will solve more difficult questions. In the meantime, when you watch this video, go to the comment section, tell me what topics or what area of indices that you're having difficulties with, or any other topic you think you're having difficulties with. You put it there. When I read the comment in the next class, I'll attend to that. Good evening and welcome to another edition of Maths with Ablight. We're looking at exponential equation. This is more for those in senior secondary school, SS2, SS3, those preparing for their GCSE exam, those preparing for their SSC exam, GCE, and all of that. Now you're asked to find x if 1 over x is equal to 27 raised to the power of x. This is no problem at all. It is very simple. It looks very cumbersome. It looks very scary when you see it. You'll be like, oh, but this is the simplest math you will think of. Now the first thing to do is to come here and write solu here, shown. Do not forget, solu here, shown. Then you tell them we have. What do we have? 1 over x is equal to 27 raised to power x. Now you want to, there are 2 x's. You want to remove the power so that you are left with this x. What do? This is simple. You are supposed to divide here by x, divide both sides by x. So, but this is a power, it's not the ordinary x that you have. So what do? Instead of saying divide by x, come here and then multiply it by 1 over x. If you want to divide something by 2, you can just simply say times 1 over 2. For instance, if I have 6 divided by 2, it is the same thing as writing 6 over 2. 6 over 2. And this is also the same as writing 6 times 1 over 2. So I have not done anything, I only did the same thing here. Instead of writing divide by x, you simply say times 1 over 2. This bracket sign is a sign of multiplication. Now we continue. If you have done it to the right hand side, do it also to the left hand side. Come here and then raise it to the power of 1 over x. Now this means that 1 over x all raised to the power of 1 over x is equal to 27, because slight cancellation jives, do not forget that word, slight cancellation jives, we are left with 1. 27 to power 1 remains 27. And then you continue. This 27 can be expressed as 3 raised to power 3, which is 3 times 3 times 3, and that is 27. So 3 raised to power 3 is 27. And so you have 1 over x raised to power 1 over x is equal to 3 raised to power 3. The base and the bases are equal. So what do? The next thing, you equate exponents. At this point, you write and tell the examiner, equating, you have to tell the examiner you know what you are doing. Equating exponents jives. Equating exponents jives 1 over x is equal to 3, because base, that is the shape of the base to the power, is the same thing. That is, the base itself resembling the power will give you the same thing as 3. This base resembling the same thing. They have similar shapes, so because of that you take out only the powers to equate, and that means that x is equal to 1 over 3. And that is your answer. I'm sure you know what I did here. You cross multiply and then you bring 3 down this way. 1 over 3, x remains here. So this is the final answer from there. I hope that is clear enough. The next one, you're asked to simplify 16 over 81 all raised to the power of 3 over 4. Solu here shown, do not forget Solu here shown. You have 16 over 81 raised to the power of 3 over 4. 16 can be expressed as 2 to the power 4. 81 can be expressed as 3 to the power 4. All raised to the power of 3 over 4. This under laws of indices, 2 over 3, everything raised to power 4. This powers of 4, you just pick one of them. And then there is already 3 over 4 here. You raise that one again to 3 over 4. This is simple. Slight cancellation jives. 2 to power 3 over 3 to power 3. 2 to power 3 is what? 8. 3 to power 3 is what? 27. And that is the answer, even in Lagos.